I wanted to just start by reiterating the theme of this conference, which actually I really like. I don't like a lot of the conference theme titles, I don't know about you, but this one's pretty good. Reimagining teaching and teachers in a changing world. And I think it's very relevant, especially, we've been talking about AI, should we have more online, should we not? There's all these different kinds of argumentations, but for me, regardless of what happens, the world is changing very fast. And the kinds of skill sets that students need, not just students, all people need, are rapidly changing. And I think Korea is one of the places that we need to also think about it more. Although this research is not done in Korea, I think one of the things that can address these changes best, we need better, more critical thinking, really more involved learning so that people can learn to make better decisions, that they can think beyond what the computer can do. Right? Because I think the easiest way to think about AI, I don't know if you'd agree with me, is that all you need to do is to think of what can AI not do well, and what will it not do well for a long time, and those are the places I think that we need to invest the most in. And so I just want to maybe raise up hands, or who here has heard of the term active learning? 1, 2, 3, 4. Okay, yeah, most of you, yeah. Do any of you have any examples of active learning, like anything? Just throw it out.
Memorizing.
Memorizing, okay, as in like with flashcards?
Yeah.
Okay, yeah, flashcards, okay. And any other forms of active learning? Yes.
Put their idea to producing a video and then...
Produce a video, yeah. Doing something, and then, but there's a lot that goes into that, right? There's a lot of complexity to producing a video, right? Because it's not just planning it out, you have to also think about what the frames will be, and there's a lot that is involved. Anyone else, any other examples of active learning that, because there's so many different types.
Group work.
Group work, yeah. And what?
Something that is similar to student-centered learning?
Yeah, student-centered learning, right? So this can even be, sometimes we do it as easy as something as just they have a manipulative, or maybe a lab where you measure something, right? Or little kids, they might have a ruler, they measure, right? There's so many different kinds of active learning. And so before I get into that, I wanted to start with the active learning because the title of this presentation is Evaluating a University's Chemistry Course Design Using the ICAP Framework. This goes beyond chemistry, but that just happens to be the population that I studied. But I think the interesting part of this is actually more about the ICAP framework. Okay, so as an introduction, the ICAP framework, it stands for Interactive, Constructive, Active, Passive. And it is a theory that was theorized by Dr. Mikichi. She's quite formidable. If you don't know of her, you should look her up. All it does is theorizes that deeper learning happens when you do more difficult cognitive tasks. That's it. It's a very simple thing, but it's something that we haven't really thought about thoroughly. I will say that one framework that teachers have used for a long time is the Bloom's taxonomy. Have you all heard about Bloom's taxonomy? Did you know that the Bloom's taxonomy was never meant to be a learning framework? It's only a taxonomy for types of test questions. Bloom in 1956 was tasked by the Chicago School Board to categorize types of test questions. So actually, the Bloom's taxonomy is mostly just for assessment creation. It was never meant to be a learning tool. Yet, every teacher I know, myself included, has used the Bloom's taxonomy as if it's a learning tool, a teaching tool. So in many ways, the ICAP framework, I think, is positioned as a really good replacement for Bloom's taxonomy because it has similarities, but the major affordance of the ICAP framework is that the categories are based on what you can observe as a teacher, a researcher, a principal. So it's based on what you can see in the classroom, right? So this is an empirical framework. You can actually see what's going on, okay? There's 4 categories. I'll go through in a second. I know there's actually a lot I need to teach you the more than present here. Okay, so this study that I did here, it applied this framework to evaluate chemistry course design and its relationship with student performance. So what are the 2 affordances of the ICAP framework? And I'll get more into the actual meat of it. The 2 things is that, number 1, it predicts the depth of learning. When I say depth of learning, it means that, for example, we just had talking about language and Russian, right? But let's say English. Most Korean people learn English in Korea. It's unavoidable now. But if you go to the average Korean person, if I just walk into any subway station and I start speaking to them in English, I will actually have a lot of people who understood what I said, but they can't talk back to me. Because that's a higher cognitive task. That requires deeper learning, right? When I say deeper learning, I mean, cognitively more demanding things, right? And finally, it's what we call a nested hierarchy. What it means is that as you move from each level, from passive up to active to constructive to interactive, we're adding things. So it's not that they're completely discrete categories, but you're adding these features, okay? So the first feature for passive is attending. So passive learning, you probably know because that's the opposite of active learning. That's most of what we do, especially in Korea, right? There's someone in front like me, lecturing, the crowd doesn't really get involved, you listen. Or maybe I'll say, read this for 30 minutes. That's passive learning, right? Because these are things in which we are just attending, as in you're attending your attention, if that makes sense, right? And the active, this is the place where it's different from when what you know as active, is that what this framework does is that it splits active up into 3 categories. Because if you think about it, the difference between measuring a beaker versus collaborating, cognitively much more demanding, right? To be collaborating than just to measure something, right? Yeah, at the same time, when we think active learning, if we just say active learning, they're both active learning. So then the question is, can we think about it in a more deep way? And that's what this does. So number 2 is manipulation, right? As in you manually doing something, measuring, right? So that's what creates active mode. And then constructive mode is generation. And when I say generation, this is a really interesting thing to think about. It means that you are constructing a new idea or thought in your mind. It doesn't have to be new to the world, but it has to be new for yourself. Does that make sense? Right? So as in you don't have to be like, oh, I have to create a new physics concept. No. You could be learning something that has already existed, but if it's new to you and you're learning that, that's called generation, okay? And that's constructive mode, right? And that happens a lot of times when we ask students to do something complex, like produce a video, right? There's so much learning that you need to do that kind of a task. And finally, collaboration, right? And that's what creates what we call the interactive mode. The collaboration part, and here's the caveat, is that collaboration oftentimes is really unequal. The kind of collaboration that the ICAP is looking for to hit that category is co-generating and equitable contributions. This means that you can't just be like, oh, you'll do this half and I'll do this half, and we bring it together. That's called jigsawing. That's not interactive mode. So interactive is when you sit together, you actually talk through the ideas together. I say something, you say something back to me, I say something back to you, and I'm like, oh, maybe that idea is this, or no, maybe not. We're like, I think we have a good compromise here, and you finally have a product. That is the type of collaboration that we're thinking about in the interactive mode. I did quite a bit of explaining here, but this is a little graphic that I made to make it a little bit more helpful. It's a lot to read at once. But if you look here at the examples here, right? For example, listening to a tour guide, watching a video, pressing a button. Originally this framework was for a museum, but self-explaining, right? Sometimes you need to explain something to yourself, right? You talk to yourself, we talk to ourselves a lot, but sometimes you're just thinking to yourself, self-explaining. Or if you just do something like comparing and contrasting, right? You're creating something new. And then finally, interactive, dialogical reasoning, maybe the Socratic method, co-generating questions, debate, right? Model UN, we talk really great things about this, right? And so hopefully you have a better understanding. I'm gonna move on because otherwise I could just talk about this framework for about like 10 hours. There's a lot to do. Okay, so then what's the driving question of this research? Does the design of courses for deeper learning, teaching strategies, does it lead to improved student outcomes? Simple. And the actual research question, because I did this because I wanted to clarify for everyone first. Sometimes, because you lose the meaning when you read a research question, is that to what extent do learning activities and learning materials as measured by the ICAP, and then I made a rubric, this is my creation, how does it predict student final exam scores and course grades? So here's the context. This is my data. I graduated from Arizona State University, and there's just a few really large Southwest universities. I won't tell you which university it is, but you might be able to infer based on what I said. But a very large public university in the Southwest in the United States. Introductory chemistry course, fall 2019 to 21. And as you can see, this falls before and in the middle of COVID. We had 5 instructors, 13 sections. We wanted more, because I think there were a total of about 12 that we could have pulled from, but only 5 agreed to participate. We had 13 sections, 3,277 students, so quite a good end for making some kinds of multiple regression kinds of conclusions. The data that I used was mostly just Canvas course shells, which included things such as course schedules, syllabi, homework. Recitation, I didn't actually have assignments, but I know when they were doing it, and what kind of questions they used. Any recorded videos, because some professors elected to, instead of having a lecture fully, they'll put the video, or they'll do both, right? And then finally, there are lesson plans, materials, and then finally, I had a few very short, very basic instructor interviews. This wasn't like, I wasn't asking anything difficult. It was just like, how long do you think the homework should take? Like, and it's very simple questions, okay? Okay, so the study used what we call ICAP dosage. So, just so you get used to that language, ICAP dosage is just the time students spend engaging in that mode of engagement. So let's say I'm lecturing at you most of the time, but for 2 minutes I make you do something together. Well, so then you have 2 minutes of interactive, and then let's say you have 58 minutes of passive, right? So this is all it is. It's just a proxy for levels of engagement, but I was trying to give time to it so that we can kind of find a way to maybe see, does time and exposure to this, is that what really can affect change? Okay, so here's the data procedure for ICAP dosage. So first, we had to rate the activity, whether it was lectures, homework, laboratory recitation. So for example, lectures, passive, homework, actually it was actually either active or constructive only. Because it's active if the questions were very simple. Like, for example, what is this? But then it was constructive if the questions made you have to think something new. Right? And so we'll get to that more. But it's only active or constructive because homework, you're supposed to do it by yourself. We don't know fully always. But like recitation was either active or interactive. So it was active if the questions were really low level. It's interactive if it's high level. Because not only is it constructive like homework, now you're doing it with some classmates. And so recitation. But then most of what I found is most of the dosage was still at the active level because it was so dependent on the question quality. So then we calculate the dose as in the time based on information from the syllabus, like for example, like a course has this much time. Well, I can assume that we had this many minutes of lecturing. And then so the difficult part was when it came to other learning materials like homework. And so I had to interview the professors to be like, well, how much time do you think this homework should have taken them? And this is a very, very crude measurement, but it's really hard to measure the average of all the students, how long they take, because it's very variable. But I think that it was a pretty good measure in general. And then finally, that's what I just said, we just estimate the dose. Okay, so next. So here's some examples. Which of the following is an element? Is an element, right? That's the major question, right? Active. Right? We're going to get all this information. Will it have expanded to its maximum volume? Right? And that's not something you can easily just say, just give it yes or no. You have to really figure out what happened. Right? So this would be considered constructive. Rank the 3 types of bond in order of strength. Right? Although sometimes ranking can be more powerful of a tool, this could have actually been turned into constructive if it said, explain why you chose the ranks. But here, all it is just rank, which is manipulation. You're just moving something into position, right? And then finally, which of the samples release the most amount of heat upon cooling from this? Explain your answer, right? So all of this part might actually not be as interactive or constructive. It's asked to explain your answer, but then now that just elevates that question. And so this was interactive because this is a question that I pulled from recitation, right? And so these are kind of categories that we chose. And so here are my results. Interestingly, given social science research, we have some pretty strong R values and R squared values for the final exam, right? We have about 35% of the model is explained for final exams based on the split of these 4 ICAP doses. And we also controlled for whether the course was online or whether it was done synchronously. And we also controlled for incoming high school GPA, because obviously if you come in with a lot of usually you'll know a bit more chemistry if you have good grades in high school, right? So we controlled for age, because we have students who are like 22, students who are 18, dependent. Pell Grant, it's not the best marker for socioeconomic status, we know that, but at least it gives us some information to pull from to be like, oh, we had some students who were a bit more economically disadvantaged, and this was the control. And we also control for whether they're first generation college students, as in they're the first person in their family to go to college. And finally, whether they're part-time or not. There are actually other categories that were in the grader model that I've extracted out, but these were the significant ones. And so what we can see from here is that there's some math that was done with calculating, because if you look at these values for dosage, right, these beta values, they tell you whether it's in the positive or negative, but the dose is really dependent on what the mean and the standard deviation of the dose was, right? So for example, on average, in most classes, there was a lot of passive dose, probably thousands, right? Versus some classes, the interactive dose was just minutes, right? And so we needed to do some calculations. So these are the calculations I did. Based on this information, I can say, well, for final exams, the passive dose predicted 1.58 points more per hour. So lectures increased the scores of final exams. Active dose, as in where they just did like basic questions, basic laboratory work, they actually lost points per hour. Constructive dose, about equal to passive dose for improving test scores. And finally, interactive, recitation, this is only recitation right here, 2.62, you can see a clear difference, right? And so I'll talk more about, this doesn't feel like it's predictive, but I can actually explain that. But let's get to this, course grade. Course grade was actually a bit more clear, right? Passive dose decreased the course grades. So the more lecturing that existed in the course, the average student did worse. Okay, comparatively to the other sections, right? And we obviously it was controlled by course instructor, so this is across course instructors. Active dose, not significant, no effect. So as you can see, active dose, we think great of active, but constructive dose, it increased 0.54 points per hour for the course grade. And remember, course grade is much more than just an exam. But look at interactive dose, 3.32 points per hour. So, what this shows is that you actually don't need that much constructive and interactive dose to make a big difference in learning. So here, I basically just said all this, so I'm going to move forward. And so here, we have some limitations of the study, right? This is not an RCT. This was secondary data. This was for my dissertation, and so I just wanted to graduate. And collecting all this data real time is difficult, but it gave a lot of limitations in terms of the quality of the data. I would have loved to observe, I would have loved to have been there, right, to more directly interview, but this is all secondary data. And it was from spring of 2021, and as you all know, well, in Korea it was much longer, because y'all kept me out of Korea for a long time. I was trying to come in, but you had like a 6-week quarantine, and I was like, no, none of that. Only 5 instructors. Here's the thing that might explain the passive being positive for the final exams. We did not ascertain the nature of exam questions, but I can probably assume that the majority of the exam questions are pretty basic questions. Whereas there's going to be a few questions, usually the free response, the ones at the end, that are going to ask the more difficult questions, right? So in this sense, maybe yes, lecturing is very good at predicting the scores of basic questions. That just makes sense, right? But then why do we see such a powerful difference with constructive and interactive in general? I do believe it's probably for those few questions that were difficult. But I don't know for sure, that's something we need to look into more. But we have other research that kind of shows this already, so I'm extrapolating that. So finally, recommendations. Relatively small changes. Relatively really small changes, as in just a few minutes of constructed, just a few questions in your homeworks. We had high association with improved student academic outcomes for final exam and for course grades. Improve the quality of questions asked so that they can go beyond memorization, skill, practice, and listening, right? And finally, we should find ways to allow students to collaborate on these higher quality questions and assignments. These are things that we know as teachers, but here it is, here's your proof. So now you can tell them, right? So that's my presentation, and thank you so much.